This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. On this video, we're going to solve this nonlinear polynomial inequality. X cubed minus x squared is greater than 9 minus 9x. So the first step is to write the inequality so we have 0 on one side of the equation. So I want to add 9x and subtract 9 from both sides, and then I'm going to go ahead and write this with the degrees or the exponents in descending order. So I have x cubed minus x squared plus 9x minus 9 is greater than 0. Now we have to factor. All right, well that's another whole subject. How do you factor something when you have an x cubed termed? And there's different ways of doing this. One method that I try with 4 terms is by grouping. So if I group the first 2 terms together, but this is really scratch work. You know, on the side you have to figure out how to factor this. I'm just going to show the steps here, but this might be something you sort of do on the side. There's more than one way to go about this. So if I factor out an x squared, this gives me an x minus 1, and out of this grouping I could factor out a 9, which is x minus 1. And now I see the common factor of x minus 1 times x squared plus 9 greater than 0. All right, so this is the factorization, and then what do? We set each factor equal to 0 to find any critical points. So I have x minus 1 equals 0, or x squared plus 9 equals 0. And remember, we're trying to find real numbers because we're going to write our solutions on the number line. So for this first one, we have x equals 1. But for x squared plus 9 equals 0, there are no real solutions here. You can first write that as x squared equals negative 9, and then when you take the square root, you'll get plus or minus the square root of negative 9. But that's plus or minus. That's the square root of 9 times I, which is plus or minus 3i. And those are not real numbers on the real number line. So we only have one critical point, and that's at x equals 1. All right, so I'm condensing this down a little bit. Here's our original inequality. Here's the factorization, setting each factor equal to 0. We only have one critical point. Now notice this time I have greater than 0. We don't have an equal sign, so 1 is not a solution. So keep that in mind. 1 is not a solution, so we're going to use a circle on it on our number line because we only want numbers that are greater than 0. We want positive intervals. So when we multiply, whatever we put in for x, right, when we multiply them together, these two factors together, we want to get something greater than 0, which means it's going to be positive. All right, so what's our next step? We put the critical point, and there's only one critical point, 1. So we write a number line, and we have this number 1. Okay, it's the only one place it is, and we know that 1 is not a solution because if I plugged in 1, let me say it one more time, if you plugged in 1 into this line right here, you'd have 0 times something, and 0 is not greater than 0. Okay, so we know 1 is not a solution, so we're going to put a circle on that. All right, so now we're ready to do our test points. We're going to test a point to the left of 1 and to the right of 1. All right, so to the left of 1, how about I test x equals 0? If I can, I always test x equals 0 because it's easy to plug in. And we have 2 factors here. So if I put in 0 into the first parentheses, 0 minus 1, that's a negative number. And if I plug it into the second parentheses, if I put in 0 in, it's going to be a positive number. 0 plus 9 is going to be positive. So a negative times a positive is negative. So I know if any points to the left of 1, when I plug it in, I'm going to get a negative number, and I'm trying to find intervals where I'm going to get a positive number. So this is not part of the solution. I want you to look for a moment at this factor x squared plus 9. notice that no matter what number you put in for x, when you square it, it's going to be 0 or positive, and then you're adding 9. So no matter what, this second factor is going to be positive. Some of you may have noticed that. But if not, you just plug in a number and you'll see it's going to be positive. Okay, now let's test a point over to the right of 1. Okay, so like how about, any number you want, how about 5? All right, so we're going to put 5 in for x. So we've put in 5 here. We have 5 minus 1. That's going to be 4, or a positive number. That's the most important thing. And the second one, by what I just told you, is always going to be positive, right? 5 squared plus 9. Hey, you're adding two positive numbers. Okay, so a positive times a positive is a positive. So to the right of 1, I'm going to find solutions. I'm going to get some solutions. So now we know that this is part of the solution set. So in interval notation, solution set, we've got from 1 to infinity. So the solution set is, it doesn't equal 1, so we start at 1 and to the right forever. And that's our solution to this problem. And here it is written graphically. Remember, you could always put these test points in the original inequality. It's just easier usually to plug it into the factored form. So in other words, you could test 0 into this original inequality, x cubed minus x squared, that's 0 minus 0, is greater than, and then you're putting in 0 on the right side, 9 minus 0. 0 is not going to be bigger than 9. So again, you would find out that this is not going to be a solution over here. So that's another way to use the test point. You put it in the original inequality and you see if you get a true statement or a false statement, and that's how you tell whether that's part of your solution. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.